Welcome to a special 15-year anniversary episode of Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today it's my pleasure to welcome Dr. Tina Brower-Thomas of the Center for Integrated Quantum Materials, an NSF Science and Technology Center involving Harvard University, Howard University, MIT, and the Museum of Science in Boston. Tina is based at Howard University, where she serves as the center's education director and is also involved in research. Tina, thank you so much for joining us. Can you tell us a little bit about yourself and how you got involved in nanotechnology?
So I'm originally from the Washington metropolitan area, and I had the benefit of a great public education in Montgomery County Public Schools. And then I went on to Howard University and got a degree in chemistry, which as a chemist, you understand that chemistry is inherently nano. So I would say I got involved in nanotechnology quite early. But nevertheless, I finished my PhD at NYU in New York, NYU Poly. And my work in my PhD was in molecular self-assembly, which was taking molecules and assembling them on gold surfaces to make hierarchical structures, which a lot of people would say that is a bottom-up approach to nanotechnology. So really, in the middle of my thesis, that's where I really started to do nano. And in order to understand what I was building and to characterize it, I had to use tools that could see things on a nano scale, like atomic force microscopy and electron microscopy. I would say I really got involved during my PhD time.
Well, that's great. Can you tell us a little bit more about the Center for Integrated Quantum Materials, where you are now?
So the Center of Integrated Quantum Materials is a center between Harvard, Howard, MIT, and the Museum of Science in Boston. It also has a college network, which I can discuss later. But what's essential to these four institutions being together, particularly the research institutions, is they all were at some point had some funding in the NNIN, the Nanotechnology Infrastructure Network. And so they benefited from the resources of the NNCI to build user facilities across the country that would help support nanotechnology research. And so it just so happens that the PIs had a chance to work together, as the PI from Howard was on sabbatical at Harvard and worked in the Harvard Center for Nanoscale Systems. And so with those connections, it was understood that quantum, which is in some ways inherently nano, because we're typically talking about materials that have quantum behavior that are on the nano scale, right? So they came together and proposed a center that would investigate quantum materials, in particular for quantum computing. But it's expanded since then, but the original idea was to develop quantum materials that would have an impact on electronics and photonics. So I'm involved in the center as the education director for the center in general. And at Howard, I'm the executive director and a researcher in the area of two-dimensional materials.
So you have a common thread in the first two questions, which is the tools. So as your center is moving forward, is the use of cutting edge tools, does that remain a critical piece of the center in the work that you do?
Oh, absolutely. When CIQM first started, we had several brainstorming sessions to figure out what are our plans, what are we going to achieve, let's say in the first 2 to 3 years, the first 5 to 7 years, and the last 7 to 10 years. I should say that science and technology centers like CIQM are funded for 5 years and then renewed for another 5 years. And so we have to sort of plan out what we're going to do. And so one of the things that came up was, in order to really do quantum materials, we're probably going to end up developing research tools that examine what we eventually come up with that have not been invented yet. So yes, it's essential. And a lot of those things that have come about are based upon research tools that were existing at the time. So in order to actually work in quantum materials, you're looking at properties that are not easily probed. And so you have to come up with techniques that will allow you to figure out what exactly did you develop. We're still using atomic force microscopy or scanning tunneling microscope as a base, but people have spent a lot of time doing things in-house they've used the platform of scanning tunneling microscope, for example, to be able to probe things on a nano scale that actually can observe quantum behavior. So solid state physicists will talk about band structure and understand the properties of a crystal material based upon its band structure, but we have to actually be able to measure the band structure and see that what we think is going to happen to give us a certain property, we can actually measure it now. And that requires pretty unique tools.
So, Tina, I understand that one of your center's goals is to increase diversity in STEM. Could you share a little bit more information about that work, please?
Yeah, so the center is Harvard, Howard, MIT Museum of Science as our core research component. But with also within the center, we have what we call our college network. And our college network is housed in two basic areas. In the Boston area, you have Mount Holyoke College and Wellesley College, as well as Bunker Hill Community College. And in Washington, D.C., we have Howard University, which is the research institution, but it's also a source of underrepresented minorities in STEM, particularly African Americans. And we also have Prince George's Community College and Gallaudet University, which is for deaf and hard of hearing students. And so in terms of diversity is built into the center with the college network. So we have a summer internship that pulls only from those institutions. And with that, we get really awesome women from Mount Holyoke and Wellesley College that are often very excited about physics in particular. And at Howard, we have African Americans and also women. And obviously from Gallaudet, we have the deaf and hard of hearing. And we also really try to recruit veterans. And we have applicants from both Bunker Hill Community College and Prince George's Community College that has a high population of veterans. And those two community colleges are very diverse, not only from all over the world and the United States, but demographically in terms of their financial background and their background with often being the first to go to college. So we really work hard at building a community within the center where the research institutions along with our college network are truly a community. There's not a sense of we're trying to check a minority box, if you will. We're trying to build a community of enlightened young folks that want to pursue STEM careers and are trained in STEM education.
I want to talk a little bit more about the ecosystem. And you've been involved in nanotechnology research for some time, coming at it as a chemist. One of the observations that people share with us is that the NNI has created collaborations across disciplines, and the interdisciplinarity of nanoscience and nanotechnology and those collaborations have really changed the way interactions occur. Do you have any thoughts on that particular topic?
Well, I would say that research is very expensive. I think that's a big drive for working together and to understand what's going on you may have an idea, but as a chemist, I have ideas based upon a periodic table, what I think might fit together to give a particular property. But a physicist would look at it, maybe from a little bit a different angle than I would necessarily. An engineer also is going to look more at how fundamentally this, whatever properties I say I can make as a chemist, how it can work or how it can be applied to, say, quantum computers. They're going to think more practically about what it is that I'm fidgeting around within the lab because I think it's interesting because I just love the periodic table. That's not enough. so I need an engineer sometimes to rein me in, or a physicist to really talk about what kind of quantum phenomenon would actually come from the ideas that I have about why certain molecules will interact a certain way, or, how I could go from the chemistry to the quantum phenomenon to the actual practical application. So we all have to work together in order to make that happen. And so none of us are experts on all of it. So I work with top physicists at Harvard, and I don't understand all the physics, but they also don't understand all the chemistry. So it's a language that we have to work out. But once we work it out by continuing to work with each other, great things come about.
So as you know, we're celebrating the 15-year anniversary of the signing of the Nanotechnology Research and Development Act. This celebration gives us the opportunity to reflect on some of the things that have been accomplished or some of the advances that have been made. When you reflect on kind of where nanotechnology has advanced, what are the things that stand out to you in this area?
That's a very interesting question. There's so much to choose from. I'm going to be a little selfish and say the idea that you could isolate a two-dimensional material is to me a huge step, because now we've gone from graphene that opened the door to so many other two-dimensional materials, or just the idea. That's just one example of where we thought we understood what a crystal structure was or what the limitations were of atoms. And now this has opened the door to things that maybe some people have theorized about, because graphene, people said it's possible to exist, but to actually isolate it and characterize it, not only being able to look at the atomic structure in real time, but also characterize its properties. And then for that to open the door for other 2D materials is, to me, one of the biggest impacts.
You mentioned working with students, and you serve as the education director, and you're also involved in the Howard University Program for Expansion of Research and Education in Nanotechnology several years ago. Can you share some of your experiences working with students and promoting education in nanotechnology?
Yeah, so being African American female, I've had many experiences where people are looking at me like, what are you doing here? And I've always had a passion for exposing as many young people as possible to science. Not everyone should or wants to be a STEM researcher. That's fine. But the decision not to do it shouldn't be made for a person. So I believe in exposure. And just in my own experience, it was one thing to sit in the classroom and learn about organic chemistry. And it was fascinating enough because I really wasn't sure where I was going with it as an undergrad, but I knew I had to get this knowledge because there's certain tools you just got to get in your toolbox. So I went through the classes, the physical chemistry, the analytical and all that. But it really wasn't until I had my first research experience in polymer synthesis that I really started to put together structure property relationships. Because in polymers, you could actually see what PMMA is going to look like versus polystyrene. Even though they both had some of the same, basically carbon-based material, they had completely different properties. And then you can change their properties depending on how they were manufactured. So as a chemist, before that, yes, I knew like maybe pharmaceuticals, they could have some outcome, but to actually see it and actually touch it and pull on it and spin it was a whole nother experience for me. And it made my experience in the classroom more relevant, like why I was sitting in the class trying to understand something. Because if I can understand this, then I can apply it to, for example, polymer research, and I can actually come up with something new and different just by having this knowledge. So I always realized that it's not enough to teach students or even to have these labs that we've been doing for generations, but to show them what's new, to show them what the future could look like, or how they could be a part of it, how they could help answer questions or solve problems. So with that in mind, I think, when I taught nanotechnology at Howard, I said, it's not enough to look in the book and study this stuff. Let's go to the lab. Let's introduce you to making a polymer or a 2D material. Let's introduce you to an electron microscope where you can actually see what you've made. And so just 1 week of a course, even where you just help students see the reality of what STEM is, I think goes a long way. And I think for sure, if it could attract me even more, because I thought I was going to be pre-med, but I spent one day and I said I have to figure out something else. but I've seen students go from not really sure what they want to do, or thinking they wanted to do one thing and realizing no, they want to do something else, and even saying, oh, I think I want to be a PhD in physics, and realizing no, I don't want to be a PhD in physics because of this experience, which I think is also important. Putting potential researchers in the place where they can start to understand how they can make a contribution, I think is really the motivation to me for expanding nanotechnology in education.
Tina, I'd like to thank you again for taking the time to talk with us and ask you, do you have any closing thoughts that you would like to share with our listeners?
I just think that in our day-to-day, we all should just really try to understand how the world is changing around us and to be engaged. I haven't talked much about science communication, but a big part of the center that I work for is science communication. Because although not everyone wants to or will end up doing STEM research, obviously, it's important to understand what it is and to listen to podcasts like this and just sort of be engaged. As I said, STEM is not necessarily for everyone, but everyone deserves a chance to be educated so they can make that choice about what they want to do with their future, and not that that choice is made for them. So I'm hoping nanotechnology would help with that, again, by making knowledge more accessible to as broad an audience as possible.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov.